Bingo. All right, so they start with some information about the consumer price index. This is a scatter plot. I think we're going to do an Excel assignment about scatter plots. That might even be the next one. Is it interesting? I don't know. It's CPI. Consumer price index is that number that measures what happens to the value of our currency. And the bottom line about CPI that I wanted you to understand is that in general, prices go up. This is historical data because the Bureau of Labor Statistics goes out and they calculate this every month. And so actually these are every single average consumer price index number from January 2011 to April 2016. And one of the things about the scatter plot is that it shows the variation in a visual way. So, if you were given a table of 64 data points, your eyes might start to bleed or something. But here you can see it kind of going up and down, but in general, it's going up. Built that I really want, but this is, I just took the black incarceration numbers. It's always good to put titles on things. So you can see that it's going down, which, let's not pat ourselves on the back too much because we're coming out of the era of mass incarceration for Black people, which has devastated communities and lives. But I guess it's at least positive that it's going down. So the point of linear models, if you say you go to the gas station and you buy gallons of gas, that's a perfect linear model. Every gallon of gas you buy costs the same amount. So if you buy 2 or 3 or 4.67 gallons, you're going to pay a proportional amount, and you can map that out in a straight line. But I think from my perspective, nobody in their right mind is ever going to go to the gas station and then think, oh my God, I want to make a linear model out of this. So this is a more like real life scenario. It's not perfectly linear, but you could kind of imagine taking a ruler and putting it down next to those numbers and saying, yes, there is a pattern, there's a trend here, and it seems to be going down, and we could come up with a model to represent that. And we'll circle back to this at the end and say, here's our model. But I also wanted to show you another aspect of this, which I think is useful. And again, are you ever going to really go this far in looking at things? It's hard to say. I suspect the answer is no. In real life, you wouldn't, but it depends on what you do with your life. In Excel 3, I had you look at real student data about homework scores and then write something about the students' results in the class and compare that to their averages, the different averages that we took. One of the things I was trying to get at was homework is theoretically important, and I'm not going to sit here and tell you that it's not important and don't do it because it's a waste of your time. I think it's a really good use of your time. It's a way to practice, and you have this built-in platform where you can get feedback about how well you understand a topic, which of course leads to being able to do quizzes and tests and things. But this is a mathematical way of analyzing whether a student's homework is related to how well they do on a test. And if you look at the picture on the next page here, this gives you just kind of a qualitative way of describing what you're seeing here. When you have things that are tightly grouped in a line, that's a strong correlation, right? It could be strong positive, that's on the left here. It could be strong negative, that's what's on the right. If you have things that are kind of loosely in a line, that's more moderate, right? And I would say this CPI thing, this is more moderate, because even though I could imagine putting a ruler down through this, and yes, it's generally going up, a lot of fluctuation. So I would call this a moderate positive relationship. And then in the middle, you have things that don't have a relationship. Like there's no real correlation between these two things. And it's a way of analyzing the world, right? If you have a hypothesis like, man, I think that poverty and crime are probably related, right? Then you could go out and you could try to study that. And of course, it's pretty complicated because a lot of times when we try to measure things, we use proxies like, how many arrests are there? Well, that's not necessarily a good measure for how much crime there is, right? Because then you're getting the police involved in the middle of all that. How do you measure poverty? Do you measure people's income? Do you measure how many people are using government assistance programs like SNAP, TANF? So anyways, it's complicated. The thing is that if you want to answer questions about whether things are related to each other, whether there's a connection between them, a scatter plot is a way to look at that. I can turn this into a linear model using Excel, but the reality is that this data shows that there's really not a good relationship between how well you do in your homework and how well you do in your test. And the upshot of that is you've got to find a balance personally about doing your homework. You need to practice, because how else are you going to solidify the things that you need to know? But on the other hand, right use of your energy or time. Okay, so let's get specific here in terms of what we want to accomplish. Let me give you my 2 cents on what that looks like. Okay, so these are kind of the 3 big things I want to accomplish, and I'm going to have to make some cuts in terms of how much time to spend on stuff, because I also want to get a little bit into section 9 here. I want to make the connections. We're going to use them to make predictions, and we're going to interpret the slope of linear models provided to us. That might be the one that I cut and just make a separate video for you to watch. Some basic things for you to know. You probably want to write down y equals mx plus b. That's the general structure of the linear model that we're going to use. It's not the only structure. There's lots of ways you could write a linear model. But for our purposes, that's what we're going to do. And so one of the things that's weird about this section is that our goal is not to come up with a number, right? Like, for instance, in the warm-up problem, I said, find the absolute and relative change, make a sentence out of it. So really, mathematically, that boils down to here we're actually figuring out numbers, but for the purpose of creating an equation. And that feels weird to a lot of students. And sometimes they just go past where they need to be because they're trying to keep filling in more numbers so that they can use the equation and calculate something. But actually the point is we're trying to make an equation. When I say model, it just means equation. Make a linear model. That means make an equation that looks like y equals mx plus b. When we make exponential models, we say y equals a times b to the x is our point, but we're going to make an equation. Okay, so let's get started with a simple example. We'll just kind of do a few of these as thinking about to make these. Not going to do much from the book here because I think that I can just kind of drill down to what's most important here. So first question, let's just assume there's a store with a membership plan. Back when I was a kid, people were buying CDs. There was all these CD membership plans, and you could join this club and then get CDs for this discounted price. So let's say the membership fee is $25, and then you get books for $10 each after that. So we can turn this set of words into a linear. Now, thinking about the definitions here, let's just talk a little bit about this and how this applies. N stands for slope, and which comes from French, I think. Sorry that it's not S. That would be more helpful. And it's about how things change, right? So there's a word in this, there's a number in this scenario I just gave you that's about how this total that you're paying is changing as you buy more books. We're not going to focus so much on graphs. We're never going to like start with a graph and then come up with an equation. That's more what you would do in an algebra course. The b value is what we call the y-intercept in math, and that has to do with where things start. So you can think of this as if my number is 0, if I'm just getting started, how much can I have to pay, or where's the situation going to begin? So as we think about this one that I gave you, which one of these is the slope, and which one of these is the y-intercept? Can you tell? Just based on those ideas. The slope is how it changes, and the intercept is where it starts.
So it starts
25. Oh.
No, go ahead.
It starts with 25.
Good. 25 is where it starts, right? Which means that the other number should be how it's changing, right? Which is 10. And so very simply, this model would be y equals 10x plus 25. Okay. Let's look at another one. The number of people waiting in line is 375. They are taking people 5 every let's say every minute. That seems crazy. I don't want to wait that long. Okay. So I'm not going to write any notes under this one right now. I want you just to write down first the form of the equation. You should have that on your paper. And then if you want to put the notes, you know, what does M stand for? What does B stand for? And what are those numbers? Then you can finish the model. The end goal will look like this. Y equals x plus Right now we're just building models. We're not using them. We're not making predictions. We're not doing calculations. Just looking at the words, and we're coming up with what number goes where. This every time in a long I'm in there counting and figuring out how to get it. All right, what do you got? M, B.
Y.
So, yeah, go ahead.
Y equals 5x plus 375.
Okay, what do you guys think? Agree, disagree?
I agree.
So first of all, we got the numbers into the right place, right? The 375 is about the starting point, and the 5 is about how it's changing, right? But there is a connection here back to what we talked about on Wednesday, which talked positive. Okay, what do I mean by this? Well, I'm going to make a little XY table, and I'm going to think about whether this equation that I've written is correct. So I know that if X was 0, then Y would be 375. What do I mean by that? Well, if I say Y equals 5 times 0 plus 375, and I do that calculation, I get 375. This is what I don't like. If I then go to 1 minute and I say, okay, where are we now, right? So represent that mathematically. How is the change happening? Is it an increase or a decrease?
It's a decrease.
If it's a decrease, then how do I represent that? Change this slope number to represent the fact that it's a decrease. Because remember, with absolute change, 5 means plus 5, which is an increase. And so what number do I want?
You want 5 minus?
Good, I want 5 to be minus. So my equation is going to be minus 5x 375.
Okay.
Okay. Now this is where it gets hard, right? Because there's the word decrease is not in that question. You got to think about it, make the correct identifications, which you guys did, but then you also have, is this one negative? Is this what's happening? That this table structure can be a nice, quick way to kind of check through. All right, let me make x0, let me make x1, let me make x2, and see what happens. Is my number going the direction that I wanted it to go? Let me give you another example of a curveball question. Okay? There's not going to be any negatives in the question itself. It's going to just have words that talk about things that imply that there's a negative. A group of students buys $300 worth of supplies to fundraise. They sell their baked goods at $4 a piece. Make a linear model for how much money they make total. Okay, so I'm trying to be clear about what kind of equation I want here, because there's different equations I could write. But I want to write a profit equation, which basically says this is how much money we made at the end of the day, taking into account how much we sold, but also taking into account, what we had to buy at the beginning. Give you a little minute for that. You can always text me if you have questions. Use the chat. Okay. First, can we just identify who's M, who's B? Then we'll try to get the numbers together into an equation. So which one is the slope? Which one's the y-intercept? What do you think?
$4 is the slope and 300 is the y-intercept.
Okay, it was a little bit broken up, but I heard 300 was the y-intercept. Here's the equation that Darian proposed in the chat, which may or may not be what you came up with. What do you guys think about that as an equation? Does that sound pretty good? Let's use our little XY table as a way to check.
I did it different. I'm not sure
Okay.
if it's right.
Yeah, what did you do?
I did y equals 4x plus negative 300 or minus 300.
Good. So we have a couple options to think about here. So if we start with 0, and this is where I always recommend you start when you're just using the little XY table to check your thinking. One of them starts at 300 and one of them starts at negative 300. So think about the significance of that in terms of profit. It would be really sad if this happened, but let's just think about it. They go, they buy their supplies, and then they go to the fundraising and they sell nothing. What did they make? 300 or negative 300? What's more accurate in terms of what happened?
The negative 300.
Right, because they're in the hole, right? If they sell nothing, they're in the hole 300. If they sell one thing, now they're only in the hole minus 296. So this first one was good in that the 400 and the 4 and the 300 were working in the different directions, but we'd have to have them the variables defined differently to have the right numbers. We just have with. Okay. So that's the basics of creating a model from a sentence where all that's provided is something about the change and something about where you started. Okay. Let's look at another situation where more information is provided, and so there's a little bit more math to do. Let's say we have something like linear model, same thing, y equals mx plus b, so the goal is the same, but you notice that what I provided to you was different. I didn't give you 2 numbers, I actually gave you 4 numbers. It's like, wait, overflow here. And don't just try to stick 98,000 and 93,000 into M and B. That's not what's happening. I would argue that one of them is the starting value. So that is actually given to us directly. M is the slope, B equals the y-intercept. One of them is about change. One of them is about the starting point. I would argue starting point is right. Which number could we use as our starting point? Oh, got some in the chat. Yes, good, Darian, 98,000. So, and that's because 98,000 was the town's population in 2000. That's not when the town began, but that's the first piece of information, chronologically speaking, that's provided to me, right? So that makes sense as a starting point. So one way to think about the problem is that now I'm down to figuring out what is my M going to be. right? Now, I don't know if you have already gotten into this, but in the middle of your textbook, there is a formula sheet. And I would take the formula sheet out and move it somewhere to the front, more visible. You're going to be using it a lot as we go on now for the rest of the course. Let me see if I can just scroll to it quick. Here we go. I think it'll look something like this. So this one is 236. I don't know if that's similar to where yours is. The thing I'm wanting to point your eyes towards is this. Right? So this is provided to you. You can use the formula sheet on any quiz or test. It tells you that M is a ratio. And if I correctly, that's how I defined it here. It's a ratio of change, right? The physical definition is it's a ratio of change. And the ratio is the change in the y divided by the change in the x. Now that definition is not super helpful in terms of identifying who's on top and who's on the bottom. So I need to give you another little hint that I would carry around with you as you do these problems. I would say that, so we're going to use the ratio of change formula, and keep in mind that in general, our time will be on the bottom. So our time variable here, we're going to call the x. And that happens because when we're thinking, we normally let time be what we call the independent variable. And I could talk more about dependent and independent variable, but it's not worth a lot of your brain space to be wrestling with that concept, because it's more of like if you really were going to go into statistics and think about these correlations, that's where you would get interested in it. So I want to use the ratio of change, and in words, basically, I want to know the absolute change in both of these situations in terms of people and in terms of time, and I want to make a ratio out of those two numbers. Okay, so that's kind of the word explanation for that formula. Find the absolute change for people. Find the absolute change for years. Make the ratio, that's your M value. When you finish, you should, don't leave it as a fraction. Who loves fractions? Well, I mean, that's what we do with our ratios in general. Okay, I'm going to give you a minute for that, and then we'll check in. We want to find the ratio of change in this situation. Okay, anybody come up with this ratio of change? This is M we're talking about. We're trying to find the slope. We just need to find the absolute change for people, find the absolute change for years, make the ratio, bada boom, bada bing. What do you got? How did the number of people change in this situation?
There's 5,000 less people.
Right. And that's the sentence. I'm just looking for the number. The important thing is that it's negative, right? Because it was, if you knew it's not in the formula sheet, I think it's useful for you to keep in mind, like, oh wait, I just did that. I know how to do absolute change, new minus old, boom. Okay. Because it's easy to just do 98,000 minus 93,000, but then that messes up your sign. Okay. Absolute change for the years?
10.
10. And then the ratio would be minus 500, right? And again, you can get the division backwards if you set that ratio up wrong. So keep in mind, in general, time's going to be on the bottom. Right? I just say in general because it's not like a hard and fast rule. I can do this any way I want, but in the problem that we're going to do, times on the bottom. Okay, let me give you a minute to try a problem. And I'm gonna think about the pivot over to exponential models, but I wanna give you a chance to apply these, well, what we've talked about, and then make some predictions using that. Let's do this one about weight loss. I think it's on page 95. Again, I'm not sure if that's a couple pages, 93, 97. But this is a question about David. He's at 240 and he wants to lose 2 pounds a week. And the questions here, if you want to skip right to E, go for it. You know, we haven't really talked about dependent and independent, but again, I'm just trying to save your brain power for what's most important. You should be able to put the model together just based on that little description at the top. And then the next part is this: how much is he going to weigh after 4? How much is he going to weigh after 10? When's he going to reach his 180 target weight? So that's what I want you to do. And I'm going to stop sharing this. I can share the question here for those of you who don't have your. Let me know if you have any questions. Okay, you guys ready to talk? Or you need more time?
I think I'm good.
Okay. So let's go back to the full screen share here. Okay, so first step was to come up with the model. This is David's weight loss. Y equals, what'd you come up with? So we're looking for the model, which means x plus .
So I did -2x plus 240.
That's what Darian got too, posted in the chat. Right, this makes sense because our starting point's 240 and we're losing 2 pounds. That's a decrease of 2 pounds. And then from there, there's 3 follow-up questions. These are the make a prediction type of extension questions you can expect. Now, when you do these problems, you can do these algebraically or you can do them non-algebraically. By algebraic, I mean you're using the equation as a structure to do it. When you look at the videos, if you look at the Section 7 videos, she's going to do it algebraically because that's kind of the math teacher's sense of like what this is all about. And oh, look, we can prove to you that algebra is really useful. But in reality, you don't have to use algebra to solve these problems. So start with y equals -2x plus 40. You want to know where is he 4 weeks after. The algebraic approach would be taking 4 and sticking it into the x value, right? The non-algebraic approach would be, hey, 2 times 4 equals 8, and then 240 minus 8 equals 232. Okay? So when you finish calculating this part on the right, you get 232, but of course that's just 4 times 2, and then take that away from 240. All right, so that would be the answer for the first one. 10 weeks, we'd be looking at -2 times 10 plus 240, and that I think would be 220. And then this is the one that arguably is most reasonable to use the algebraic representation for, which is trying to figure out when would we want, or how long would this need to go on for if we really lose 2 pounds a week in order to hit 180. Again, you don't have to do this algebraically because you could just start with your 240, take off the 180, that's the target. That means you got to lose 60 pounds. And then what would you do to the 60 to figure out how many weeks you need to do it for?
Divide by
yeah, go ahead. Yeah, divide by 2, because you're going to lose 2 pounds a week. So how many 2-pound weeks do you have to do to get to the answer? The answer is 30. algebraically, what does that look like? So basically, I would say you subtract 240 from both sides. And then, oh my God. Put equal in front of that, man. Okay, subtract 240 from both sides. Then you have minus 60 equals minus 2x. And then you divide both sides by -2. And that's how you end up with x equals 30. Now, if algebra was never your friend, if it's been a long time, you're going to need a little bit of more support and guidance on how to actually do that. And I'm happy to put some time in to help you work on those types of problems. But the purpose of the course was not to focus on algebra. And so this is just another example of there are multiple ways you could solve this problem. Don't get hung up on something that's got limited use in your daily life, right? I'll tell the other math teachers I said that. All right. Now, there's a little bit more to talk about in terms of what you really need to be able to do for linear models, but that's the heart of it, right? Two kinds of sentences or setups. One in which you're given the slope and the intercept, and then you turn that into an equation, and the other in which you're given some data, and then that can be used to come up with a model, right? So before we go on to exponential models, let's turn our attention back to that original data set, because we had something that looked pretty linear. And if this is a pattern that we can then extrapolate, and I don't know what the underlying things are beneath this. I imagine that there's some decriminalization efforts that are making some headway. There was a big federal bill that was signed, but I think one of the things that had led to black mass incarceration was the war on drugs, police going in and continuing to criminalize black men in particular, and then locking people up and throwing away the key and that sort of thing. So if we're making progress, it's going down, good. Let's just apply what we just learned to create a model for this situation. So let's use the 2008 and 2018 numbers to come up with a linear model for how many black prisoners there will be in year X, which we're going to call years after 2008, and then use that model to predict the population in 2028, 2025, whatever. Okay, so let's unpack this sentence because it got pretty long and complicated. And again, I think this is a skill. This applies to the summary questions in Excel. You get a bunch of text and you're like, oh my God, there's a lot of going on. Compartmentalize it, break it up and say, okay, well, first I need to do this, then I'm going to do that. Basically, the first thing is to come up with the model, right? And to come up with the model, you probably want to break down, this is a lot of information, this is a graph. You want to break down this so that you can focus on just what you need. I need the year and I need the number of prisoners. And I'm talking about black prisoners. So what are the four numbers that you need that are coming out of this table? That's the first step. And kind of go from there. I'm going to just stop talking for a little bit and give you some chance to think about what you need, how you're going to proceed. If you get stuck and you're needing help, just send me a text, say something out loud, and I'll jump in. Okay, so tell me about the ratio of change. What'd you do?
I did like the absolute change. So I did
Good.
200 or 465,200 minus 592,800 divided by 10.
Good. Okay. And then we finish that, of course, don't leave it there. And so that becomes what, 12,760
Right.
negative, right? Because it's
Right.
going down. Okay, so then we're ready to make our model. Y equals,
Okay, I'm confused on where the 10 is coming. Where's the 10? Oh, the number. Okay, I got it. Never mind.
oh, all right.
Okay.
Sometimes talking is generative, and as you talk about things, you make connections. Or I know that it's one of the good things, I guess, about working at home. If you're not working with other people who are going to judge you, you can say things out loud and see if it helps you put stuff together. Okay, so Y equals what? So we're looking to fill in the two numbers to make our model. Y equals X plus
So I got y equals negative 12,760 plus 592,800.
Okay, now I'm not sure if I missed it because of the audio cutting in and out, but this actually is a pretty common mistake, so I'm just gonna pretend like you made this mistake. There's something missing in this equation. Can you see it?
Oh, the x.
The X, right? So this might be a scaffolding that's helpful to you, and you really don't need to write these two steps out separately. You could just, on paper, write y equals mx plus b, and then write y equals, give yourself a blank, x plus blank, and then you're filling stuff in from there. Okay. Cool. So from there, then we can turn to the second part of the question, which is predict 2025. Now, it's worth not just blowing past this point because it's kind of another little curveball here. What do we do to figure out the population in 2025? Again, ideally using the model. Now, we don't have to. There's a non-algebraic way to do it, but especially if we have we're feeling good about how to interpret ratios, right? I mean, what does this minus 12,760 mean? Let's take a minute and interpret that before we answer this 2025 question, because this would be the non-algebraic way to approach this problem. What does that minus 12,760 mean in the context of this problem?
That's how many less prisoners there are each year.
That's right. The number of Black prisoners is going down by 12,760 per year. Okay, so if we understand that, and by the way, that is a ratio interpretation, so you can use some of the ratio interpretation skills that we did. We did kind of rephrase it. I didn't just say for every negative 1,207, for every negative 12,760 Black prisoners, there's 1 year. That's not a good version of the sentence because this is about change. So that's one difference, right? This is like maybe how you would have interpreted it if you went through the process and applied what we did in the first part. So I would say not good, good. So to make the shift over to, a sentence that recognizes that we're talking about change, you just need to get the idea of change into it. You can still say for every 1 year, but you need to talk about how the number is going down or going up, as the case may be, right? Okay. So the non-algebraic way to do it would be to make this happen, right? I mean, whether you start with the 2018 number or the 2008 number is up to you. 2018 is closer to 2025. So if we start in 2018, we're starting with this number and we need to go down that much every year for 7 years. And that would give us our answer. Now, if we want to use the algebra, and again, I should encourage you to do that because that's in some ways an easier way to do it than going through all this interpretation and then trying to think about how many years you need to go by. The number that you plug in is really the hard part here. Like, what does X need to be in order to use this equation? And the answer is, well, give you a chance to answer it yourself. Anybody have a guess about what they would use for X there?
I was gonna say, do you subtract the 592 800 on both sides, and then divide by the 1276?
Well, we would if we were solving for like when are we going to get down to 100,000 prisoners? Then we would do that process. But if we're just working out what X is, we really want to ask ourselves, how many years has it been since 2008? Because that's when we are calling it the starting point is 2008. So if we're talking about 2025, how many years is that after 2008? And that's going to be our X value. Right. So Darian
17.
says in the chat, yeah, X equals 17.
Okay.
So that's what we plug in. We take this equation and we just plug in the number 17. Okay, multiply, add, and away you go. So I'm just going to do it with Excel because Excel is a big calculator. 592 800. Okay, so looks like it'll be around 375,000 prisoners.